Ken Thompson and Dennis Ritchie started building the Unix system in 1969. They found a structure which simplified many aspects of the interactions between computers and people. Thompson and Ritchie were aiming to keep their system simple, and they found a collection of primitives that enabled them to do a great deal with a very few primitives.
You're living in a world built by something you can't see, a digital ghost, an invisible architect that's been shaping your reality for over 50 years. Right now, as you watch this video, it's there, in your phone, in the cloud storing your photos, in the servers delivering this video to your screen, in the traffic systems managing the streets outside your window, in the hospital equipment keeping people alive, even in the Mars rovers exploring another planet. It's called Unix, and its story is one of accidental genius, silent revolution, and a legacy that runs deeper than the internet itself. But here's the twist. This is also a story of how something so fundamentally brilliant could tear itself apart in a commercial war so bitter it nearly destroyed everything it had built. Today, I'm taking you on a journey through tech archaeology. We're going to dig up the code that built our modern world and the corporate greed that broke it. But before we dive deep, a quick disclaimer. I'll be simplifying some technical details to tell this story. The real implementation is far more complex, but the core impact remains profoundly real. Let me take you back to 1969. Not the Woodstock 1969, not the moon landing 1969, the other revolution happening that year in a research facility in Murray Hill, New Jersey. Bell Labs. If you were a brilliant computer scientist in the 1960s, this was your Valhalla, your Olympus, the place where legends were made. The transistor was invented here, the laser, information theory. This wasn't just a research lab, it was where the future was being written in real time. But in 1969, Bell Labs was nursing a spectacular failure. They'd just pulled out of a project called Multics, an ambitious operating system that was supposed to revolutionize computing. The idea was beautiful, a massive time-sharing system where multiple users could work simultaneously on one huge computer. The reality? Multics was a disaster. It was complex, bloated, and slow. It tried to do everything and ended up doing nothing well. Bell Labs walked away, writing off millions of dollars and years of work. Enter two guys you've probably never heard of, but who changed your life more than most people you have heard of: Ken Thompson and Dennis Ritchie. Thompson was a programmer's programmer, brilliant, unconventional, and frankly a little bored after Multics collapsed. He found himself with an old PDP-7 computer, basically junk by Bell Labs standards, sitting unused in a corner. And here's where history gets interesting. Thompson didn't set out to change the world. He wanted to play a game. Specifically, he wanted to port a space travel game he'd written to this old PDP-7. To do that, he needed an operating system, a simple one, the opposite of Multics. So, over the course of 3 weeks, supposedly while his wife was on vacation, he wrote one. 3 weeks. 1 week for the operating system kernel, 1 week for the shell, the command interface, 1 week for a text editor. And just like that, Unix was born, named as a pun on Multics because it did one thing instead of many, and did it well. Now here's what made Unix different from everything that came before it. It wasn't just software. It was a philosophy. Thompson and Ritchie had watched Multics try to be everything to everyone and fail spectacularly, so they went the opposite direction. They created what we now call the Unix philosophy. Write programs that do one thing and do it well. Write programs that work together. Write programs that handle text streams, because that's a universal interface. Think about that. In a world of monolithic software that tried to do everything, Unix was like Lego blocks, small, simple pieces that could be combined in infinite ways. They invented something called pipes. Imagine you have one program that lists files, another that searches text, and another that counts lines. In most systems, you'd need 3 separate operations. In Unix, you could chain them together like water flowing through pipes. That single line lists files, filters for text files, and counts them. Simple, elegant, powerful. But the real genius? Everything is a file. Your keyboard? A file you can read from. Your screen? A file you can write to. Your printer, your modem, your hard drive, all files. This unified interface made Unix incredibly simple to work with once you understood the concept. And then Dennis Ritchie did something that would change computing forever. Unix was originally written in assembly language, the lowest level code, specific to each computer. That meant if you wanted Unix on a different machine, you had to rewrite the whole thing. So Dennis Ritchie invented the C programming language. Think of it as the universal translator for computers. Write your code once in C, and with some tweaking, it could run on any machine. In 1973, they rewrote Unix in C. This made Unix portable, and portability made it powerful. Here's where the story takes an unexpected turn. Bell Labs was owned by AT&T, the phone monopoly, and thanks to a 1956 consent decree, a deal with the government, AT&T was prohibited from entering the computer business. This meant they couldn't sell Unix. So what did they do? They gave it away. They licensed it to universities for basically the cost of the tape it was shipped on, a few $100s. And here's the kicker. They included the source code. In today's world, that's like Apple giving away the iPhone's complete blueprints for the price of shipping. Universities loved it. Computer science departments that could never afford expensive commercial operating systems suddenly had access to a powerful, modern system they could study, modify, and improve. An entire generation of computer scientists grew up on Unix. If you went to college for computer science in the 70s or 80s, you learned on Unix. You breathed Unix. You dreamed in Unix commands. This created something unprecedented, a shared culture. Students at Berkeley were running the same system as students at MIT, as students at Carnegie Mellon. They could share programs, share techniques, share innovations. And because they had the source code, they could fix bugs, add features, and experiment. Unix wasn't just software. They used it with software they owned in every meaningful sense. This collaborative, open spirit would plant the seeds for everything that came later. The open source movement, Linux, the entire philosophy of shared knowledge that would define the early internet. But we're getting ahead of ourselves. Let's zoom in on one university that would become crucial to our story, the University of California, Berkeley. Berkeley didn't just use Unix, they transformed it. Under the leadership of Bill Joy, yes, that Bill Joy, who would go on to co-found Sun Microsystems, Berkeley students started adding features that AT&T's version didn't have. They added virtual memory, which let programs use more memory than the computer physically had. They added the VI text editor, which old-school Unix admins still swear by today, 40 years later. They added the C shell, which made Unix easier to script and automate. But the most important thing they added? Networking. TCP/IP, the fundamental protocol that the entire internet runs on, was first implemented in Berkeley's version of Unix called BSD, Berkeley Software Distribution. Think about that for a second. The internet, the thing you're using right now to watch this video, was built on Unix. The protocols were developed in Unix. The first internet servers ran Unix. Unix wasn't just along for the ride, it was driving the car. By the early 1980s, Unix had escaped the lab. Major companies, government agencies, and the military had discovered what universities already knew. This system was powerful, flexible, and critically could run on different hardware. This was revolutionary. Before Unix, if you bought computers from IBM, you ran IBM's operating system. If you bought DEC computers, you ran DEC's operating system. Want to switch vendors? You'd have to rewrite all your software. Unix broke that lock-in. You could run the same system on an IBM machine, a DEC machine, or a machine from a dozen other manufacturers. Your software, your scripts, your tools, they all just worked. A whole industry sprung up around this. Sun Microsystems, founded by Bill Joy and others, built workstations that ran Unix. These weren't cheap desktop computers. These were professional machines for engineers, scientists, and designers. If you were designing computer chips in the 1980s, you did it on a Sun workstation running Unix. If you were doing cutting-edge graphics work, you did it on Silicon graphics workstations running Unix. If you were running serious scientific simulations, you did it on Unix. The U.S. government standardized on Unix. The Department of Defense ran Unix. NASA ran Unix. Major banks, the ones processing your parents' mortgage payments and your first credit card, ran Unix. And as the internet grew from an academic curiosity to a commercial necessity, guess what was running it? Unix. The routers that directed traffic, the servers that hosted websites, the email systems that connected the world, all Unix or Unix-like systems. Now, let me talk to those of you who remember this era, those of you who were there. If you were a programmer, a system administrator, or an engineer in the 1980s or early 1990s, Unix was your weapon of choice. Not because it was easy, it wasn't. Not because it was pretty, good God it wasn't. But because it was powerful, unbelievably, intoxicatingly powerful. While your average office worker was struggling with DOS or early Windows, you were orchestrating complex operations with simple command combinations. You could process thousands of files in seconds. You could automate tasks that would take others hours of manual work. You could reach across networks and manage systems on the other side of the world. There was a learning curve, sure. Unix didn't hold your hand. The command names were cryptic: grep for searching, awk for text processing, sed for stream editing. The documentation was terse, written by engineers for engineers. But once you learned it, you felt like a wizard, like you had secret knowledge that gave you power over machines. I'm talking to you, the ones who remember staying up until 3 a.m. in the computer lab, the soft clacking of keyboards, the satisfaction of finally getting that script to run perfectly. The ones who remember the culture, the user groups, the man pages passed around like sacred texts, the friendly arguments about VI versus Emacs. Unix wasn't just a tool. It was a community, a shared language, a way of thinking about problems. And for about 15 years, from the mid-1970s to the early 1990s, Unix was quietly conquering the world. Not in flashy ways, not with big advertising campaigns, but steadily, inevitably, like water seeping into every crack. And then it all nearly fell apart. Remember that consent decree that prevented AT&T from commercializing Unix? In 1984, that restriction ended. The phone monopoly was broken up, and suddenly AT&T was free to do whatever it wanted with its creation. And the executives at AT&T looked around and realized, holy hell, we're sitting on a gold mine. Unix was everywhere, running in universities, corporations, government agencies. Major companies had built entire businesses around it. The Department of Defense had standardized on it, and AT&T owned it. So they did what any large corporation would do. They decided to cash in. The licensing fees went up. Way up, from a few $100s to tens of thousands, then hundreds of thousands. The relaxed academic distribution model was over. AT&T was now in the business of selling Unix, and they wanted to squeeze every dollar out of it. They released System 5, AT&T's official commercial Unix, and they made it very clear if you wanted to use Unix, you'd better pay up. But here's the problem. Unix had evolved. Berkeley had been developing BSD for over a decade. They'd added crucial features, they'd fixed bugs, they'd implemented the internet protocols, and they'd distributed their version widely. AT&T said, that's all based on our code, so you owe us money. Berkeley said, we rewrote most of it, added tons of new features, and we're not stopping. And thus began the Unix wars. On one side, AT&T System 5, backed by corporate money, sold by major vendors like IBM and HP. This was the official Unix. On the other, BSD, backed by Berkeley, adopted by Sun Microsystems and others. This was the academic Unix with all the innovations. But it gets worse. Every major computer company decided they needed their own Unix variant. Sun had SunOS, then Solaris. IBM had AIX. HP had HPUX. DEC had Ultrix. Silicon Graphics had IRIX. Each one slightly different, each one incompatible in subtle ways. Imagine if every car manufacturer used different gas. Ford cars run on Ford fuel. Toyota cars need Toyota fuel. You can't mix them. The pumps aren't compatible. That's what happened to Unix. A program written for Sun's Unix might not run on IBM's Unix. A system administrator who knew HPUX had to learn AIX from scratch if they changed jobs. Features that worked perfectly on one system would crash on another. The beautiful simplicity and portability that made Unix revolutionary was being destroyed by commercial competition. Then AT&T really escalated things. In 1992, they sued Berkeley and the University of California. The lawsuit claimed that BSD contained AT&T's proprietary code and that Berkeley was illegally distributing it. This was potentially devastating. Companies using BSD-based systems suddenly faced legal uncertainty. Could AT&T come after them next? Development slowed. Companies hesitated. The lawsuit hung over the entire Unix world like a dark cloud. Berkeley fought back. They started a massive project to remove every line of AT&T code from BSD, replacing it with clean, original implementations. Line by line, they rebuilt Unix from the ground up. The lawsuit dragged on for years. Discovery, depositions, counterclaims. It was ugly, expensive, and it paralyzed innovation. Eventually, in 1994, it settled. Berkeley won mostly, but the damage was done. By the mid-1990s, commercial Unix was in trouble, not because it was technically bad, it was still powerful, stable, and battle-tested, but because it had become a victim of its own success and corporate greed. The costs were astronomical. A single user license for a commercial Unix system could cost thousands of dollars. Enterprise licenses ran into the hundreds of thousands. Support contracts added another pile of money on top. Vendor lock-in was brutal. If you built your infrastructure on Sun Solaris, you were locked into buying Sun hardware. Want to switch to IBM? Good luck. You'd have to rewrite everything. The fragmentation meant that software developers had to maintain multiple versions of their programs. Testing became a nightmare. What worked on one Unix didn't work on another. For the people actually using these systems, the developers, the sysadmins, the engineers, this was infuriating. They remembered when Unix was about sharing knowledge, about collaboration, about building something together. Now it was about license agreements, legal threats, and corporations squeezing every penny they could from what was supposed to be a tool for innovation. The Unix community, once united by a shared philosophy and open collaboration, was fractured. The empire had broken itself apart. And in that fracture, in that frustration, in that yearning for what Unix used to be, something new was about to emerge. While AT&T and Berkeley were fighting in court, while commercial Unix was eating itself alive, a 21-year-old student in Finland was getting frustrated with his computer. His name was Linus Torvalds. He had a new PC with an Intel 386 processor, and he wanted to run Unix on it. But commercial Unix was too expensive for a student. The free alternatives weren't very good. So he did what Unix hackers had been doing since Ken Thompson. He decided to write his own. In 1991, Torvalds posted a message to a Usenet newsgroup. "I'm doing a free operating system. Just a hobby, won't be big and professional." Just a hobby. Won't be big. How wrong that turned out to be. Torvalds released his system kernel under the GNU General Public License, the GPL. This was critical. The GPL said, this code is free. You can use it, modify it, distribute it, but if you distribute your changes, you have to share those changes under the same license. This was the opposite of commercial Unix. No licensing fees, no vendor lock-in, no legal threats. Just code, freely shared, constantly improving. And crucially, Linux was Unix-like. It followed Unix philosophy, it used Unix commands. A Unix programmer could sit down at a Linux system and feel right at home. But it wasn't Unix. It was written from scratch with no AT&T code, no legal baggage, no licensing fees. The spirit of Unix, the collaborative, academic, innovation-focused spirit that had built it in the first place, was reborn in Linux. What happened next was unprecedented. Developers from around the world started contributing to Linux, not because they were paid, not because they had to, because they wanted to be part of something. They'd watched Unix tear itself apart over commercial interests. They'd lived through the vendor lock-in, the incompatibilities, the legal battles. Linux was their answer. A Unix for everyone, owned by no one. By the late 1990s, Linux was everywhere, on servers, on desktops, running websites, managing networks, and it was growing faster than any commercial Unix. Companies that had bet big on commercial Unix started to panic. IBM announced they were backing Linux, not their own AIX, Linux. Sun tried to fight it with Solaris, HP tried with HP-UX, but the momentum was unstoppable. Free, collaborative, constantly improving Linux was eating their lunch. The internet boom of the late 90s built on Linux. Google's rise to dominance? Linux servers. Amazon's cloud revolution? Linux. Facebook, Twitter, Netflix? All Linux. Now let's talk about where Unix is today, because here's the beautiful irony in the story. Unix won, completely and totally, just not in the form anyone expected. Commercial Unix? Mostly dead. Sun was acquired by Oracle, HP-UX is on life support, AIX still exists, but it's a niche product. But the Unix philosophy, the Unix architecture, the Unix way of thinking? Everywhere.